Well, welcome to this hybrid event arranged by the IET's Angling Coastal Local Network, which represents members in North Essex, Norfolk and Suffolk. And welcome to those of you in the local audience here at the atrium at the University of Suffolk in Ipswich. And it's really great to be able to meet face to face again. Welcome also to folks joining via Zoom from other parts of the UK and indeed globally. So welcome to you all. I'm Kevin Foster, I'm chairman of the Angling Coastal Local Network, and I'll be your host for this evening. I'd like to introduce our speaker, Richard Mackenzie from BT. Richard is a distinguished engineer and a wireless research manager. His current focus is on creating an ecosystem for RAN virtualization, network automation, and the use of small cells. He's co-chair of the Telecom Infra Project, TIP, RAN Intelligence and Automation, Open RAN sub-project, and is also involved with the Next Generation Mobile Networks, that's NGMN, where he was chair of the RAN Functional Split and X-Hall Group, O-RAN Alliance, and Small Cell Forum, the SCF. So Richard will no doubt discuss many aspects of Open RAN. He'll be covering why some of the folks in the industry love it and others not so much. So Richard, over to you.
Thanks everyone for attending, especially those that are here in person. The short abbreviated version of that introduction is the last few years I've been working on many aspects of Open RAN. Open RAN is the Marmite of the mobile industry, and it really is quite a good analogy because to some it really is the only way forward to make sure that we've got a resilient ecosystem for the future, and to others it's an unnecessary distraction and is actually hindering progress. So what I'm going to try and cover today is make sure that you all understand the many aspects of Open RAN, and I'll try to also cover the good and the bad, why some people see real problems with Open RAN and also why it might be our savior. So that's what I'll try to cover. There's many aspects. I'll try to make sure I stick to time, so there's time at the end for Q&A, and then any bits that have confused you, you can ask me questions then. But it's a good time to discuss this because we've just had MWC, so Mobile World Congress is the biggest event in the mobile industry and one of the big focus points. Lots of operators were pushing it, lots of vendors were showing their latest solutions. But when you look at what people are actually saying, you know, the analysts were coming back with mixed reviews. Is Open RAN succeeding or is it failing? What's really happening? And the real problem is there aren't that many commercial deployments yet. There's lots of people talking about we'll deploy it soon or we'll trial in it, but there aren't that many deployments. So what I'm trying to explain today is why are we in that situation and will it, what's going to happen next? So first of all, what I wanted to cover are what are those key aspects of Open RAN? When somebody says I've got an Open RAN solution, what might they mean? So first of all, actually you can't see this, but there's in the top right of the screen there should be a core network symbol, but we don't care about the core network. This is really focused on the radio, so that's still on screen. So the radio access network in the traditional architecture, that's all coming from one supplier, and I've shown it here as one box. It might in fact in reality be several boxes, but the interfaces between those boxes are proprietary. And so is everything all right?
Well, we're just looking at that, Richard, whether we can get rid of the Zoom. It's not on mine. It's on yours.
So I don't think it's a big problem. It's always, I've always kept the core network on that side, so we don't. Yeah.
If you click the minimize tab on the top and you do the same with the closed captioning thing on the top.
Yeah.
There we go.
You can also close the bar up top as well. Yeah, close the bar at the top as well.
Down a bit.
Stop.
This. Right. Yeah. Okay. Perfect. So that's the traditional architecture. Simple. A base station that connects to a core network, and the radio access network. I've shown it as one block. Could be several interfaces, but they'd be proprietary interfaces. What we now see for comparison, now this has stopped. How did you get this working last time? click back on the slide.
Yeah.
There we go. Right. So, and then this is for comparison, the high level view of an Open RAN architecture. So the first thing you'll notice, there's a lot more boxes now. And there's a few key aspects to this, but to manage all of these boxes, we actually introduce another box. So the base station itself is composed of an RU, a radio unit, a DU, a distributed unit, and a CU, that's the central unit. And with all these boxes, we need to manage them. And so we've also got this box at the top, this blue one, the RAN Intelligent Controller. And so this can help coordinate all of these different devices wherever they are within the network. So the first aspect that I wanted to point out when people say I've got an Open RAN solution is disaggregation. So that's exactly what you see. We've disaggregated that one box into 3 distinct separate functions. And that can be an advantage to us because what we can do, we can put some of this stuff as far into the center of the network as possible. And the more we do that, the more cost effective it could be because we get pooling gains by doing all of the processing in just one central location. And we can get coordination gains because all of those base stations are being processed in the same physical location. But there can be downsides. There's a lot of latency to deal with. And some of the processing, particularly in the DU, is very latency sensitive. So we can't centralize it too much. And also the interface for front haul is a lot more inefficient than mid haul and back haul. And so the transport can be a lot more expensive if you centralize too far. So the next bit, virtualization. If you say I've got a virtualized solution, people are often claiming it's an Open RAN solution as well. And that's essentially the functionality, the digital processing that would be done traditionally in dedicated hardware is done as a software function. And that gives a lot of advantages. The most obvious one is flexibility. We can now make changes to the software very quickly. We don't have to install any new hardware. We can keep the hardware as it is and make software upgrades very often. And so as we're building 5G and trying to deliver a range of different services, it's ideal that we can actually change the software without having to change the hardware all the time. But we can go beyond that. There's also cloudification, which isn't the same thing as virtualization. It's an extension on it. So we can virtualize a function. We can have it running as a virtual function on a server. And that gives us some advantages. But if we can get that to run on the cloud, we get more. We can actually scale up and down these functions. We can move them around the network. We get resilience. If something fails, we can bring up an extra service in another location. So the cloud gives us this additional flexibility. And so we often hear about cloud native solutions. And that's another thing that people talk about. If I've got a cloud native solution, I can say I've got an Open RAN solution. I think one of the key ones is multi-vendor, or at least being multi-vendor capable. I've drawn this diagram with lots of different colors, and all the different colors mean is that could be a different vendor. And so we're just trying to emphasize that this really could be a huge number of vendors playing a role in an Open RAN deployment. And one of the advantages here is from a resilience angle, if something happens to one of your suppliers, you can get alternative suppliers that can come and fill that gap. So you've got a resilient supply chain in that sense, but also you've got competition, and that's another important feature. If we want to get the best of breed components to build our network, we want to make sure there's a choice of vendors for every component. And by disaggregating in this fixed way, we can say that people who are specialists in radios can build the best RUs. Certain software vendors can focus just on the processing in the DU or the CU, and we can always select the best or most appropriate vendor for our chosen solution. And then finally, how does this all happen, and why do we call it Open RAN? It's open interfaces. So we have to specify those interfaces between the RU and the DU, the DU and the CU, and the interfaces from the RIC down to the RAN components. Those all have to be well specified. So if they're open interfaces, that means that we can genuinely get multiple vendors to create this solution. And that leads us on to the next slide, which is, what do I mean when I say I've got an Open RAN solution? There's a few different terms that people use. So the first one to raise awareness of is O-RAN, which is the O-RAN Alliance. These are the actual this is the standards body that specify those open interfaces that we need in the architecture. And so when someone says O-RAN, that's probably what they mean, but not necessarily. The next one is Open RAN as one word. So this is a project within the Telecom Infra project. So TIP, they're trying to make sure that everyone is connected, and they want to try and encourage the development and deployment of open, disaggregated, standards-based networks. And so Open RAN is one of their major projects, which is focused on the RAN. And so they're not a standards body, but they're trying to help build solutions. So when standards are developed, or while standards are still developing, they try to build solutions to prove that they work. And when they don't work, to actually take those findings and go back to the standards bodies and say, this is what we need to make it work. Lost it again. There we go. So then there's Open RAN. There's two words. It sounds very similar, but it's different. So this is a more general term, and this can just mean about anything you want it to mean. But it's supposed to be the sort of the industry movement that's looking for virtualized, disaggregated, open networks. People often talk about having an O-RAN solution. Again, I don't know if that's an abbreviation of open or if it's O without the hyphen, but it's very often said. And people also very often say, I have a RAN solution that is open. And sometimes that doesn't mean it's Open RAN, particularly if they're talking about, I've used some open source software. That doesn't necessarily make it an Open RAN solution. And in fact, most Open RAN deployments don't necessarily have open source software. So that's something to look out for. But the main message from this is, and I'm as bad as anyone, I mix these terms up myself, but when someone says I've got an Open RAN solution, you really have to ask a few more questions to find out which aspects of their solution is Open RAN. There's a few key focus areas that I wanted to identify. First of all, the most mature part of Open RAN. So we were working on this sort of 5 or 6 years ago. This is the open front haul interface, and this was the origin of Open RAN. We needed a more efficient front haul interface that was better than an interface called CIPRI. So this is from the traditional architecture. CIPRI is very inefficient. So if you've got, for example, if you have 100 megabits per second of user traffic, you might have a few gigabits per second of front haul traffic. So it's really inefficient, and it scales up linearly with the number of antennas that you use in your base station and the amount of spectrum you use. And the unfortunate thing for this interface is, as we move from 4G to 5G and 5G to 6G, we're using more and more antennas and more spectrum. So it was already really inefficient, and now it's unusable. So we needed an alternative interface, but that's now well standardized, very mature. Lots of vendors deploy it. Even the vendors that are looking to use traditional architectures are starting to use open front haul in their deployments. So now we're moving on to two other areas that we think have got the most promise. The first one is the RIC. So that's the controller that coordinates all these different components in the architecture. So it's essential just to make Open RAN work, but it's also potentially the thing that makes Open RAN a success, because it can automate processes, it can optimize performance. So it can be the reason that we can get Open RAN to perform as well as legacy architectures, and hopefully in the long term outperform legacy architectures. We'll talk a bit more about the RIC later on, but that's one of the key focus areas. And then we've got the DU. So as I mentioned, the DU does a lot of intense processing. It's very latency constrained. There's a lot of repetitive processes, and you can virtualize it, but it doesn't necessarily suit running on a server. It would consume a lot of core processors, and it might not perform that well. So this might be an area where we need some dedicated hardware that actually performs some of these intense processes, such as forward error correction. And so these two diagrams that I've got on the side there, don't have to go into too much detail. All I'll point out is the green boxes. So these are showing how accelerators can be used on a virtual platform to try and help us deal with some of these intense processes. And the two main options, the one at the top, we see we've got these two green functions. These are look-aside accelerators. They just deal with one particular function each, and the virtualized aspects do a backwards and forwards message exchange. So one of the downsides to that is the exchange between accelerators and the virtual platform, but we're not relying on too much hardware. And the alternative at the bottom is to just say, well, most of that low layer processing is intense. Let's just do it all in hardware. So it's sort of cheating. You're not doing anything virtualized anymore on those lower layers, but you are getting the processing done in the most efficient manner. So the trade-offs vary quite significantly depending on the deployment scenario. So we want to investigate this, understand it better, and make sure that there is a good ecosystem of suppliers that can provide accelerators so we can actually build the best of breed distributed units. What does Open RAN look like? Well, I can show a few examples. So this is from a project that DCMS did in Manchester with Vivacity, Transport for Manchester and Weaver Labs. And it's basically got an Open RAN radio, just here, a little square box. That's the radio unit. The antennas are at the top to connect several nearby traffic lights. And then what we see here, just a cabinet, and they've opened up. I'm not sure if this displays very well, but there's a little grey box in there, and that's doing all of the virtual functions. So it's quite straightforward, and we've got something very similar in our labs. So here we've got a white box that we have up a lamppost. That's the radio unit, and then all of the virtualized functions are just running on a server. So it's very hard to show an exciting picture of a server. This fourth one down, that's the server that we're using in this deployment, and that's running a central unit, a RIC, and a core network. So onto macro networks. These are some radio units from the macro network, and these are not actually Open RAN units. These are what are in the deployed network. So these are using the traditional architectures. So the only thing that's different is they're using that inefficient CPRI interface. But the main message here is that actually the radio units for Open RAN and non-Open RAN solutions will look exactly the same. So if you're walking around trying to spot Open RAN, you really have to look for the logos of the company rather than the shape of the box. And all of the virtual stuff, that just looks like a data center. So it's very hard to spot Open RAN just from visual inspection. So what are the early opportunities? The reason I brought this up is because there are mixed messages about Open RAN. Is it already a success, or is it struggling? And then there was a further interview with our CTO asking at Mobile World Congress what he thought about Open RAN, and the headline says that we're playing the waiting game, but actually all he said was for urban deployments we probably need several more years, and that's the most challenging environment to deploy radio. So you need high performance radio. We need to prove that it works, prove that it can deal with high traffic density. That's a real challenge. So I agree with that. The thing that's missed there is that's for the most challenging environments. There are other environments where we can deploy Open RAN much sooner. The first of those opportunities is neutral host. So that's where a single deployment can provide a service for multiple operators. And the neutral host installs all of the base stations and manages all the infrastructure. The only thing that they need to do is connect back to the mobile core networks. So in this example, and this is a slide I presented about, I think in 2018. So we've been working on this for a long time, and we're nearly there with a working Open RAN solution. But what you can see here, we've got 3 different core networks from 3 different operators, and then we move into the neutral host domain. And so the neutral host just has to provide a cloud platform or a virtual platform that all of the operators can share, and they can all deploy their virtual functions on that same single shared platform. And then the neutral host deploys one set of radios everywhere that they want to provide coverage. And this is ideal for neutral host. We get coverage for all the operators that are involved, and we've had one installation, and they're sharing one virtualized cloud platform. And the reason this stands out from legacy architectures is when you do sharing in the past, you always make cost savings. That's the reason you do it. But there's a real drawback that sharing with your competitors is a real problem when you want to upgrade. So if you want to negotiate, I want to stand out from my competitor by adding a new feature, I now have to get permission from my competitor to add that feature into the hardware. But now everything's virtualized. We can do that without having to go through such tough negotiations. So this actually enables us not just to provide coverage with a neutral host solution, but we can remain competitive, so operators can still try and upgrade and compete with one another, even though it's a shared environment. And that's all. That's just me adding the logos that I'm using on today's presentation. So that's all that's changed in those 5 years. There's been a lot of progress, particularly in the UK. There's a specification called JOTS, which is basically an organisation of the 4 UK mobile operators, and they've agreed a set of specifications that a neutral host has to use to design their solutions. And then the operators are willing to do an integration exercise to allow that neutral host to provide services. So that getting that agreement between all the operators is a real benefit. And so that's why the UK might be the world leaders in the adoption of neutral host, and particularly Open RAN neutral host. And Small Cell Forum, they've been trying to push those ideas out to the global market. The other big opportunity is private networks. So private networks, every private network's got its own proprietary requirements. So you want a specialized network, and that's going to cost a lot of money. But with Open RAN, you can take components that are available in large volumes, but you only want a small amount of them, and you can piece them together to build a network that satisfies the requirements that you have. And in particular, this is where the RIC becomes really exciting. We have these things in the RIC called XApps. So these are individual functions, and each one has its own responsibilities for some form of optimization or automation. And when we've got a private network with its own specific requirements, we can develop XApps that can tailor the network to do exactly what you need it to do. And we can do all of this with essentially commoditized components rather than proprietary one-off components. So those are the two big opportunities in the short term. So now I'm going to go talk about the architecture a little bit. And I won't go into all the detail of this. This is quite a tough diagram to look at. But this is what the architecture looks like from the O-RAN Alliance. What I will point out, though, is the scope of their activities. So you'll see there's some black lines on there, and those are interfaces that are standardized by 3GPP. They're the main standards body for the mobile industry. What O-RAN Alliance do for some of those interfaces is just add profiles to try and reduce the amount of optionality in those specifications, because one particular interface is X2, and that's the interface between neighboring base stations. And that's a well-defined interface, but it's got so many options that every vendor implements it differently. And so we can't get neighboring base stations to talk to one another unless they're from the same vendor. And so what O-RAN Alliance have done is add profiles to try and make interoperability between different vendors possible. The green interfaces, those are the interfaces that O-RAN Alliance have defined themselves. So overall, you'll see there's interfaces between all of these disaggregated blocks. And then also we've got the management system at the top. And that's another one of these problems when we've tried to do multi-vendor deployments in the past. The northbound interfaces are proprietary. So you end up saying, well, we've got an open interface between the blocks, but the northbound interfaces are proprietary. So actually, I'm still locked down to a particular vendor. So by having this unified management system, we can genuinely build this multi-vendor deployment. One of the big questions is, where do all these different components go? So I'll just put a couple of examples here. So one is for a national network. So this is what the BT network looks like at a high level. As you go from the access side on the left to the core on the right, you'll see we go through a series of different aggregation levels. And so we've got tier 1 nodes where we've got about 1,000 nationally. The metro nodes about 100, and then we've got these core nodes where we've got around 10. So the more we can centralize things, the more we can pool all of that processing into one location. And so it makes sense that we would put the central unit into those core sites. We'd ideally like to do that with the distributed unit, but because of the latency and the cost of the transport to get there, it actually might not work. So more likely we would want to deploy a DU at a tier 1 site. That has a big drawback that there's now 1,000 sites that have to manage the DU rather than 100 or 10, but we'll be saving a lot on transport and we'll be meeting the latency requirements. And then of course the radio units, they have to go at the edge at the cell sites. The other opportunity is we could put the DU at those cell sites, but again, that's even more expensive. There's more DUs to manage. And then we've got another example for a smaller deployment. So if we're doing an enterprise for a single building, it might be very easy to decide where the components go. We know we need several radios on every floor. We need them to coordinate a lot, so we'll give them one common DU. And then all of those floors need to aggregate onto one CU, so we can just put that in the basement with the core network. So that might be a very easy thing to do. But this is just to give you an idea of the flexibility and the scale that Open RAN can be deployed in. It really can do small and large deployments. And I've talked a bit about coordination gains. So if you have a common DU, you can, sorry, the diagrams is changed from what I thought. But you can have a common DU for several RUs. So all of those RUs can now coordinate with one another. So if you've got two RUs that are next to each other, they might have overlapping coverage, so they might interfere with one another. So if they've got a common DU, they'll have a common schedule, and so they can manage that interference a lot more effectively. And likewise, if you've got multiple DUs going back to a common CU, then everything with a common CU is technically the same base station. So when you hand over between those cells, the handovers are going to be a lot more reliable. So there's always coordination benefits to being on a common CU or DU. But we still will have neighboring base stations. So that X2 interface that I mentioned before, that's still really important that is open, so that we can coordinate between neighboring cells. There's a lot of discussion in the last few weeks about, do we need this coordination between neighboring DUs? So there's some big fights going on. So if you want to see people getting upset, this is the discussion to follow, because there's some real benefits to this. If we want to enable real-time scheduling in a multi-vendor deployment where we're achieving high capacity, we're going to have to deal with multiple RUs and potentially multiple DUs coordinating with one another. So there could be a real benefit to having that interface, but at the same time, there's a real drawback that there's a lot of real-time processing going on there. And now if we have an interface sharing all of that information in real time, it's going to slow things down. It might mean that the schedules can't work effectively, so it could actually hinder performance. So it's a real battle. So that we're looking into this at the moment. So you may hear more and more about this D2 interface, or you may hear nothing more about it. But now I'm going to talk about why the evolution of the architecture is very well suited to Open RAN. So in a cellular network, one of the most challenging things is, how do we deal with that user at the edge of the cell? Every generation of technology, we're talking about better peak rates, but actually the peak rates don't actually stand out as much as the bad performance. If you're at the cell edge and you don't get very good performance, or you can't get any service, that's going to stand out and affect you more than a slight improvement in peak rates. So there's been a lot that's been done in the past to address this, and Open RAN's in a very good position to help continue that progress. So if I just go through the simple example in a cellular network, that cell edge user is being served by one user, and they're just in coverage. They're at the edge of that cell, so they've got a very weak signal. Then they've got two neighboring cells which are also transmitting. So you're actually as close as you can be to those interferers. So you've got a weak signal and strong interference, and that's the reason why you get such poor performance. So what's happened? One of the major technology benefits here is through massive MIMO. So we can do beam steering. We can, rather than send out a signal to an entire sector, we can say that there's the user, I'll focus all my energy towards that user. So that signal that's intended for the user can be stronger and better received. We can also say to the interfering cells, while we're serving this edge user, can you serve users in a different location? That way your signals aren't interfering. So we get a stronger signal and weaker interference, and that really improves performance. But we can still say, well, that edge user is still at the edge of that, the coverage area of that cell. What else can we do? Well, we can send a signal from this base station, and we talked about these other two interfering cells. Well, what if we change that interference into a signal that we want? So we can actually get multiple cells to broadcast a signal to that intended user. So now they've got a much stronger signal, and that can work in the downlink as well as for reception in the uplink. This is called coordinated multipoint, and the real challenge here is the coordination. Any of these base stations need to share a lot of information in real time, and that's where this X2 or XN interface becomes vital again, and we need to make sure that's an open interface. So what we're actually getting to the point now is where we don't necessarily think of each cell, each base station as a separate cell. We just think of the base station as part of the transmission and reception. And it could be neighboring cell sites that actually overall become a single base station, creating that transmission for the user. So we move away from a cellular architecture to a cell-less architecture. And you might hear this referred to as user-centric, because now we're just seeing where we've got these transmitters. These are just cell sites. Well, cell sites is the wrong word now. These are base station sites, and overall, several base stations can provide the service to a user wherever they are. The other term for this is distributed MIMO. So we're rather than just put more and more antennas at one location, we can now put lots of antennas in lots of locations, and overall we get a huge number of antennas that can provide the signal that's wanted. And this is where Open RAN, as a head start, it's already got that aggregation, that coordination between neighboring cell sites. And this is why I think that Open RAN, even if it's not a success today, in the longer term, even the traditional architectures are going to evolve this way, and we're going to see this happen more and more. Supply chain diversity, you might have heard that one, and I've not mentioned it so far, but this is one of the other big reasons that we need Open RAN. So if you look at this diagram, you'll see a lot of, well, they're all old logos now, but you'll see a lot of logos from companies that no longer exist. And so you'll see some great names, and you'll see that there was so much competition in the mobile ecosystem a decade or so ago. And over time, through mergers and acquisitions, we've narrowed it down to just having 3 major suppliers. So we refer to them as the big 3. There are other RAN vendors, but these 3 dominate the market. And in recent times, the UK government and other governments have been looking at security of national critical infrastructure. And so the UK government have decided that there's a list of high-risk vendors we can't deploy in the network. This big, unfortunately for us, Huawei are on that list. So that brings us down to having a not very competitive 3 vendors to an even less competitive 2 vendors. And the main concern, if we talk about a resilient supply chain, what if something happens to Nokia or Ericsson? We're now with a monopoly. And what if something happens to both of them? We're in real trouble. So it's having a resilient supply chain is one of the main concerns for the government. And so they see Open RAN as an opportunity to create a more competitive ecosystem with more vendors and make sure that the supply chain is global. They're putting a lot of money. The US government have put in 1.5 billion to help develop Open RAN. Germany have done about 300 million euros. UK government have put forward 250 million pounds. And they've done a number of things. And if you look at their objectives, it looks very similar to what we've been talking about: disaggregated networks, open interfaces, resilient supply chain. And what we see in the pink box, that's just a list of things that they've already done. So they've established several collaborative projects that are called the Future RAN Competition and the Future Open Networks Research Challenge. I'll talk about a few of them later on. But these are projects to try and help build Open RAN solutions, different components within the ecosystem to make sure that there's a good UK presence in that global supply chain. And then there's the Sonic Labs, which is allowing vendors to come in and test their kit and show that it performs to a commercial standard that it could be deployed. And that's really there to help component suppliers. So vendors that aren't planning to build all of the components, they might just have one special unit, and so they need to have an environment where they can test it with everyone else's kit in a vendor neutral location, and that really reduces the barrier to entry for the smaller vendors. And there's the UK Telecoms Lab, which I don't think is ready yet, but will be ready soon, and that's mainly focused on doing security testing. Hot off the press, so this week the UK government have done another initiative. We've got 80 million behind this Open Networks Ecosystem Challenge, and so they're looking to do some more collaborations to make sure that there's a strong UK presence in Open RAN. They're looking at these 3 areas, and the first area is high demand density. So that might be looking at that biggest challenge of, can we get Open RAN to work in high density environments? And then the other 2 areas are pretty much what we were talking about earlier, is the 2 big areas for development. So one is the RIC. Can we really show the potential of the RIC? Can it enable multi-vendor? Can it enable true optimization and efficient automation? And then the reality of implementing ORAN. We want it all virtualized, but there's still a lot of dedicated hardware that we actually need to make Open RAN work effectively. And so can we make sure that those components are actually built and part of the competitive supply chain? So now we'll focus on the RIC. So I've mentioned the RIC already, but if we look at go back to the architecture diagram, we'll see that actually there's a couple of RICs in the architecture. There's a non-real-time and a near real-time. So one of them works on anything that's over a 1 second control loop, and near real-time, as you'd expect, on shorter control loops. But essentially, they're all doing automations and optimization functions. And within the RICs, we've actually got, you'll see within the near real-time RIC, the functions that do all the various optimizations are called XApps. And in the non-real-time RIC, they're called RApps. And that's what we see actually as one of the real opportunities for Open RAN to stand out. Those XApps and RApps can come from anyone. It doesn't have to be one of the RAN vendors. There could be a specialist who just creates one XApp that does one particular thing. And also it gives an opportunity for the operators. They know their customers as well as anybody. They might be able to create the XApps and RApps to optimize the network for their intended customers. So it really does make Open RAN flexible and it enables us to tailor the solutions to do exactly what we need. In TIP, we've got a sub-project called TIP RIA, and we're trying to commercialize the RIC. And to do that, we're trying to focus the entire industry on the key objectives. And these are the key use cases that we're trying to get the entire industry to focus on. And I won't go through them all because we don't have time, but there's 2 main areas. There's the ones that I would say that they're your basic bread and butter, what you need from day one. If you're going to have an automated system, there's certain functions that you expect to have. You need automatic cell ID selection. You need energy saving features. You need load balancing so you can transfer load between neighboring cells. Those sorts of features are what we often refer to as SON, self-organizing networks. But we've also put some other more challenging use cases in here, and particularly those that mention MIMO. So MIMO is about use of multiple antennas for transmit and receive, and so that can enable you to get much higher capacity networks, and it already enables a huge increase in performance. But actually, if you compare it to what it theoretically can do, we're still far off its potential.
So if we can get more optimization via the use of the RIC, then we might be able to show significant benefits over traditional architectures. So although that's not something we need to see in the short term, it's one of the big opportunities for Open RAN to stand out. And so we're also trying to address that from day one. So I think we've got a few minutes to go through what BT are doing in our current activities. So I think just about everyone in the room is familiar with Adastral Park, so I won't spend too long on this, but for those of you who are not familiar, Adastral Park, it's BT's technology HQ. It's here at Martlesham in Suffolk, and that's where research is based. That's where I work, and that's where we do most of our Open RAN testing and development. If we look on this diagram, this is a screenshot from a YouTube video where we were showing our current test bed, and what you'll see, we've got a lamppost here, and at the top of the lamppost we've got a radio unit, and then at the bottom of the lamppost we've got this cabinet, and that cabinet can host any transmission equipment, any power supplies and things that the radio unit needs, but it can also provide compute capacity. So we've got rack space in there, so we can host a DU in that location if we want to, and all of that then fibers back to our data center, and at the data center that's where we can put all of our normal virtualized functions, so our CU, our RIC, any applications, any core network functions, that can all be back there. And we've got a number of these lampposts scattered around the site, so we've got a test bed where we can test things in the lab, but then we can go outside and show, does Open RAN really work in reality? And that's an important thing to prove with Open RAN. So we're currently, the pictures you see here are from our current setup, which is working with Acceleran and Viavi, and we've got a Viavi geolocation XApp and an Acceleran handover XApp, and they work together to make informed handover decisions based on the geolocation information. So what's really interesting there is we've got two XApps from different vendors coordinating with one another to give optimized performance. We're just about to take that down and put up the next setup, which is based on our DCMS project, ARI 5G. So that's also focused on the RIC, but we're addressing several other use cases from that list that I showed you before. And we've also got the DUvolution project, and as you might guess from the name, that's focused on the DU. And they're really looking at what is the platform to support a DU. We know it probably needs acceleration, but it might also be doing a lot of aggregation. We might want some local compute in that area. So can we build a box that can host the DU and any other functions that need to be in that same location? And then we've got the Proteus, which is also looking at the platform to support Open RAN. They're really looking at silicon diversity, and can we make sure that there's a rich and competitive ecosystem in the silicon market for supporting Open RAN. We've also got a few other projects that are just starting. So Be Green, which is focused on energy savings, and then we've got these FON-RC projects. These are all led by the universities. So we've got University of Bristol, Surrey and York. And so they're looking at Open RAN, but in sort of slightly longer term view. And so over the next year or two, they're going to be delivering things to Adastral Park as well for us to test. So one last slide, things to look out for. So hopefully you've learned a few things about the many aspects of Open RAN. But when you hear people talk about Open RAN, I think there's a few things that you need to listen out for if you want to know if they've got a real Open RAN solution, or if they're trying to indicate that Open RAN is really maturing. So the first thing to look out for is multi-vendor. Are people talking about a solution? They list the vendors they're dealing with. So if you've got multiple vendors, there's a good chance it's a true Open RAN solution, and we're seeing positive progress with Open RAN maturity. But that's not necessarily true. You can get what we're seeing almost is sub-ecosystems at the moment. So you get a collaboration of vendors that say, we'll do a multi-vendor solution. They build together, but can you bring in another vendor later on? That's a big question. And that's why the second thing on that list is interoperability. Because if you do interoperability testing, you can actually show that you are designing your solutions to work with these open interfaces effectively. And the door is always open to introduce another vendor that you can work with. The ORAN Alliance and TIP both do Plugfest events where they do interoperability testing. And up to now, it's been mainly about demos and proof of concepts, or people from these sub-ecosystems saying, I'll just test with my preferred partner. But what we want to see in the longer term are true interoperability testing, where you turn up, this is my box, so this is my radio unit, and I want to test with all of the DU vendors that have turned up to the event. So that's certainly something to look out for. The systems integrator, that's a new role in Open RAN. When we talk about this challenge, we've got all these boxes to manage. Who's taking responsibility for that? Well, it's the systems integrator. So they're providing a lot of value in the overall end-to-end deployments. And so you might say, who wants to take that responsibility? Well, you know, if you're creating value, you can charge. So quite a lot of vendors are now trying to place themselves as systems integrators. So look out for that. You know, who's becoming a systems integrator, and one thing to watch out for: are they a systems integrator for just a sub ecosystem, or are they a truly vendor neutral systems integrator? We ideally want to see vendor neutral systems integrators, and also the operators themselves could do this role if they've got the expertise. Cloud platforms. So everyone says, I've got virtualized, I've got cloud, but have they got a cloud platform that can actually support Open RAN? And in particular, have they upgraded it with the necessary acceleration to support a DU? So if you listen for accelerators, when you hear people talking about their cloud platform, you'll see just how ready it is. And the RIC marketplace. So the RIC is possibly the enabler for the success of Open RAN to actually outperform legacy RAN. So there's a lot of effort being put in here to make it mature quickly. One of the things that I did mention, these X apps and R apps, we want them to be able to come from third parties and not necessarily a single vendor. And to make sure that that happens, we need to make sure that we're in a position where you can install your X app on anybody's RIC, or your R app on anybody's RIC. And so what we're trying to create is this ecosystem, almost like an app store, where you can say, I want to download this X app and install it on my RIC. And we're trying to at least create that in TIP. So we've got a very early version, but that's really showing X apps that have passed a certain level of maturity and tick enough boxes that their requirements match our expectations. But it's not a true app store experience yet, but that's what we're trying to develop. So that's something to look out for. And then finally, if it's a success, only if it's deployed. So we've got to look out for deployments. And there are deployments already, so it's already good. But the key, the really good ones, the major deployments, Rakuten and Dish. And that's because they're greenfield deployers. So they're building a network from scratch, and they've chosen an Open RAN architecture. So they're demonstrating the real value of Open RAN. But for the other operators, the brownfield operators, to incorporate Open RAN to coexist with their existing legacy architectures, that's a bigger challenge. And so we've got to start looking out for that. If we start seeing large scale deployments with brownfield operators, then Open RAN is winning. So that's my long or short overview of Open RAN. Hopefully it's made sense, but I'm sure I've confused you on a few things, so there will be some questions. So I think I've timed it well enough that you can confuse me back.
Well, thank you very much, Richard. This is a great presentation. A lot of food for thought there, and I know there are a few questions lined up on Zoom, and I'm sure there'll be a few questions in the audience here. So whilst we're thinking about questions, if on Zoom, it's the Q&A panel. So please, if you've got a question, put it into the Q&A panel. We've got Ian here who will manage the questions for us. Maybe I'll Chairman's prerogative. I'll kick off with a question, if I may. with all of this kind of complexity and coordination, there comes a sort of a point where, you know, despite all the best efforts on testing and everything, something kind of goes wrong. How is that solved when you've got an open kind of ecosystem, when you've got maybe different vendors with different components, and how are you going to work through that?
Yeah, absolutely. And my experience is that happens in just about every POC we've done so far. There's a lot of problems there. And the two areas that there's the systems integrator. So the systems integrator has that challenging role. They have to identify which vendor is it that's responsible, or which vendor is it that can fix the problem. So they're taking on that responsibility to find out how to fix this issue. And the other area, I mentioned a lot of this automation and optimization will be done via the RIC. And all of these features might be optimizing, doing their own thing, but actually we might have them trying to adjust the same parameters, and they might be trying to do opposing things. So we also have this this idea of a sort of a conflict resolution XApp that would be sort of the ultimate XApp, which monitors what's going on and deals with the conflicts. So that's something that's been identified by the industry, and that's one of the focus areas. So it's not solved. We're aware of the problem and trying to address it, but yeah, it certainly is that the complexity is something that has to be managed. Yeah.
Great, guys, being thought about. So let's take a question from the audience here at the atrium at the back.
Hi, Rich.
So,
One comment.
Please shout up. Because
Okay.
the owls
you'll have
can't
to
hear you.
repeat it, Kevin, for the audience.
I want to make one comment and a question, okay? First comment, you missed off the most important DCMS project from your list, okay, which is the UK TIM one. Okay, building front door to allow investment into the UK. Right. Okay, so put that on the slide. So the Rakuten dish, are they shifting towards ORAN Alliance standards, or are they kind of proprietary? What's your view?
Oof, what can I say?
Best
Yeah.
repeat the question. So,
So
Rakuten dish.
yeah, so Rakuten and Dish, I mentioned, are the more the best examples of commercial deployment. Just how Open RAN compliant are they? Well, we don't know for sure until we get to see the kit and they reveal a few more details themselves. I would suspect, you know, Rakuten were the first to go, so they will have had to make some compromises. Everything was done in one of these sub ecosystems, but at the same time, they've been trying to push for Open RAN to be standardized. So I think they'll have any shortcuts they had to make because of the early deployment, I think they'll be addressing over time. And that is one of the benefits of virtualized platforms. Even if you have to do something proprietary in the short term, you can change the software to become compliant, and the standards keep changing anyway. So that's one of the big advantages of a virtualized platform. The dish deployment is more recent, so I'd say from the start they'd be in a better position to do a fully ORAN compliant solution, but I don't know until they reveal more details about the deployment. But certainly for both of them, you would say they've got multi-vendor solutions, so that's a big positive.
Ian, shall we take a question from Zoom?
Yes, I think there's 16 questions open on Zoom at the moment. So I think we're just going to have to try and keep them a bit short.
Okay.
And we'll take one from the audience, one from Zoom. Yeah. So this is from Dean. Given the very low latency requirement of 5G standalone, do you think the disaggregation into the DU and CU will impact the low latency requirement too greatly?
Well, I mean, the flexibility of Open RAN means we can deal with it. So if we want to offer low latency, we have to push everything towards the edge, not just the radio access network, but even the applications and the core of the network. So if we want true low latency, everything goes towards the edge, and the ORAN architecture will allow for that.
Excellent. One from the audience, please. George.
One question from me, which is from someone who's not in the space. What deployments would I expect to see first in the UK? I mean, from your understanding of this architecture, the availability of equipment, what sort of things would be the sweet spot earliest in this country?
So there's already some deployments. So I think Vodafone, I think it's in Bath. They've already got a macro cell. But I think these are sort of individual sites at the moment, but they're examples of commercially ready and deployed Open RAN solutions. What I was talking about with the early opportunities, neutral host in building. I think that's going to be the first large deployment of Open RAN in the UK. And private networks, you know, that's something that I would expect this year. We'll start seeing that.
And which companies should I be looking for to see the private networks being deployed?
Well, there's a number of vendors. I mean, we're really talking about the small cell vendors. So you know, talk about UK presence. You know, there's IP Access, which are now Mavenir. So they're one of the disruptor vendors in the UK. So you'd see those. There's Parallel Wireless, another UK vendor. So well, with the UK presence. There's still the traditional vendors. That's the other thing to emphasise. It's Nokia and Ericsson have both got a role to play in Open RAN. And certainly when we look at private networks, they've got solutions available as well.
Thank you.
Thank you. Good. Possibly a yes or a no answer here. Can a DU serve one macro RU and one micro RU at the same time?
Yes, but I don't think I've seen that. Yeah.
Right, that's good enough. That's good enough. One from the audience, this gentleman, sorry.
It's your neutral host. The question that just occurred to me is who actually owns the spectrum?
Yeah, good question. So in the architectures we're thinking of that would be deployed earliest, the neutral host would be using the operator spectrum. So that's one of the reasons why the JOT specification is so important, because the operators don't let anybody just use their spectrum, and anybody that's using that spectrum could, you know, tear down some of the already installed network. So you really have to be careful, and that's why that JOT specification is a real enabler for neutral host. There is the possibility in the longer term that a neutral host could decide to use its own spectrum or some shared spectrum. For example, we've got the 3.8 to 4.2 band in the UK that would be a good candidate for that. But at the moment, we just have a neutral host using, if we've got 4 operators, there'll be at least 4 carriers. Yeah.
One from Zoom then, this is from Ruben, is the RU, DU, CU separation an Open RAN exclusive architecture, or is it already part of the 3GPP standardization?
So the DU-CU split, that is actually standardized by 3GPP. So that's the F1 interface for 5G. And then the DU-RU split is not in the 3GPP spec. And as I mentioned earlier in the session, that there's a sort of a proprietary interface called CIPRI, which is not defined by 3GPP, but that's a lot of the traditional architectures use that. So it is well established that we have that DU-CU split.
Okay, thank you. Question from that gentleman?
All very nice to be the technology and architecture, but where would you actually use it? You know, can you give me a specific use case? Why would I use Open RAN?
For open, oh right, okay. Well,
where would I use it?
Well, just as it's indistinguishable from, like I said, it looks very similar to traditional RAN. It would be used in the same environment. So in the long term, that's the big prize. Can it replace the macro?
Lights? I mean, what's the actual use of it?
All right. Well, anything that's a 5G or 6G or 4G use case, those are potential use cases for Open RAN. The big prize is can it be the macro network? In the short term, neutral host, the use case is just coverage. You know, you've got a building that doesn't have coverage, and so you're not really looking for high capacity. You just want to make sure that you've got a good signal for every operator.
It's just data. Is it or voice? Or what
it depends. So with private networks, especially, that it really can be anything. And it's that flexibility that allows you to build a network with your tailored use cases, and particularly with the RIC, you know, again, it's there for tailored solutions. So it's that flexibility rather than it being designed for a particular use case, which is, yeah, sorry, it's not disappointing, but yeah, it's ideally it should do everything. Yeah,
There is only data.
yeah.
Okay, one from Zoom then. Isn't massive MIMO, one of the techniques for which vendors are saying Open RAN is least suited?
Yes, yeah. Well, one of the arguments with traditional architectures versus Open RAN is just the performance aspect. The traditional architectures are coming from vendors who've got decades of experience. They've optimized and optimized and optimized. And so, of course, they're going to have the best performance. When you say, well, let's just disaggregate this and have multiple vendors playing parts, playing different roles in the optimization, that's gonna perform worse. And I do agree in the short term, that's certainly the case. But in the longer term, that extra coordination that we'll get would mean that massive MIMO could outperform traditional architectures, but it's going to take time, and that's why we've addressed it as something we need to start addressing now, but actually is a long-term goal.
Okay, thank you. Right, gentleman at the back.
Hi, good speech. My name is David. So in a mobile network where you have like the DUs and the CUs talking to the rig, do we just have just one rig in the entire architecture? And also, I'll need some help in understanding what functions the CU perform that makes it different from the functions the rig itself performs.
Right. Okay. So first question about the how many RICs do we have in the network? So for the near real-time RIC, again, it's responding in near real time, so it has to be close enough to the environment that it's optimizing. So you may have several near real-time RICs in a particular area just to make sure they can respond in time. But the non-real-time RIC, which is making optimizations over longer time periods, that will be highly centralized. You might just have one for the entire country, or at least one for the region. But near real-time RICs, you'll have many of them. One interesting thing, actually, now we brought it up, is how do near real-time RICs coordinate? Because there's no interface between them, so they would have to coordinate via non-real-time RIC. So that's an interesting area to look at. Was there another aspect to that question?
Yes. So like,
Oh, the function. Yes.
Yeah.
So
what the CU.
So yeah, when there's data, it will basically, as it goes through the radio, it'll go through the physical layer. So receive sample the data, try and decode it, and then you end up with a scrambled message. So the decoding is done in the DU. You have an encoded message, and that's where it goes to the CU, which decrypts it, and then it sends it off to the core network. The RIC isn't dealing with any of the user data. The RIC is just dealing with control. So it's saying, oh, the optimum parameter for power should be this, and it'll send messages down saying change the power. Or, you know, so the RIC is dealing with control and management data. The traffic that goes RU, DU, CU, that's mainly user plane data.
Okay, next question from Zoom, from Ruben. Regarding the cell-free architecture, can't this also be achieved with a centralized RAN architecture where we have a centralized pool of BBUs that manages different RRHs, RRUs, which could also be done in LTE, for example?
Absolutely, yeah. That's the point, that the front haul is the part of the architecture that the industry is adopting. But the one thing that changes is the front haul interface. So in the traditional architecture, that's where they're using CIPRI, and it's so inefficient it just won't scale for 5G, and 6G, forget it. But that's why that traditional C-RAN architecture will work, but they will have to change the actual interface so that it's the O-RAN front haul interface.
Yeah. good to get a straight answer, I think. Right, any questions from the audience? Yes, Nigel.
Hi, can I just ask about the diversification and creating this whole ecosystem? So first part of the question, is there any obligation on the MNOs to actually deploy or choose to implement the architecture? Because if not, then people are taking a risk at developing a product that may not have a market.
Well, yeah, so one aspect, it's in our interests, like I mentioned, we need a more resilient supply chain. But also the government are sort of in discussion. So there's some very vaguely worded targets to have, I think, is it 30 or 35% of Open RAN in the network by, I can't remember what date, I won't speculate, but it's later in the decade. So there is a vaguely worded target, but also it's not yet clear exactly what that means. Do you have to just have one open interface to say that my network is Open RAN? Or do I have to win, or is there a certain minimum set of features from that Open RAN architecture that have to be deployed? So it'll become clearer over time, but there are likely to be minimum requirements for Open RAN deployment.
I'm just asked to follow up to that. How well is that ecosystem developing? Are we getting a lot of activity, developing real winning solutions?
Well, yeah, I mean, we were starting from very little. As I say, there's so little competition in the ecosystem. There was very little in terms of, especially for the UK presence in mobile. So now we've got quite a few vendors through these collaborative projects that are developing solutions that are either good prototypes, but some of them are actually commercially ready. So we are actually making that bridge over into commercial deployments now.
Thank you.
Okay, a question from Dean. With different vendors supplying products and the pick and match concept, isn't this going to change the testing demands on the operators significantly, as with the existing 3GPP RAN architectures where vendors can perform a major amount of the testing?
Well, yeah, there'll still be a set of test specs that you can go through, and you can do your own self-certification. But there is this added thing of can we go to a vendor neutral lab and demonstrate that we've got this interoperability? I'll get these certifications and certificates. O-RAN Alliance have opened some OTICs, so these Open RAN Test and Innovation Centres, and that's what they're specifically there to do. So most regions have already got one. In Europe, we've got loads. So they also host Plugfest events. So yeah, there is already a set of venues that can help with that new set of testing, but it is an extra thing to do.
Yeah, that's fine. Thank you. Any more questions from me? Let's take the person at the front there first.
You had your 10 metros, 100 sites, but how many RUs are there in the network? Order of magnitude.
So in that example, so in a national network, if that's the macro network, we've got about 20,000 sites.
And then each of those has got multiple antennas. So
yeah, so each site you actually have multiple radios and normally have 3 sectors as well. So yeah, so
many lots.
So you're probably getting to the hundreds of thousands. Yeah.
Thank you. Probably a quick question here. Is Open RAN more efficient than traditional RAN in terms of energy efficiency?
Well, we don't know yet. I doubt it, especially while things are fully virtualized. Like I said, a lot of the DU processing is quite inefficient. So if we get accelerators in there, that should help. There was a lot of discussion about this at MWC, and some of the other European operators are in a collaboration, and they seem to see that Open RAN is an opportunity to outperform traditional architectures for energy saving. That was one of the things they highlighted.
Okay, thank you. Yes.
For the edge cell efficiencies you were talking about, I may be naive here, so feel free to shoot me down. One of the things you were saying, it sounded like a mobile device is connected to one cell at present.
Yeah.
The traditional way. And am I right in thinking you're saying that it could be connected to 2, even 3 cells simultaneously? So it might be like using up 1% of one cell's time, flickering over to use another 1% of another cell's time. And while you're getting a video streamed, it's kind of getting bytes from both to get maybe double, triple the rate.
Well, sort of the thing I was showing at the end with the cellless architecture was multiple base stations transmitting the same information at the same time. So when it's received at the user, it's a stronger signal, so it can just decode that message better. But yeah, there's several ways you can improve the performance.
It's not flipping back and forth. It's like getting 2 or 3 to send it all at the same time.
But if you
can't hear one, it can hear the other.
That's right. And as it moves around, the base stations that contribute to that overall signal will change.
And sorry to interrupt, but does that also work the opposite way?
Yes.
So that the 3 all listen as well.
Yeah.
More carefully.
Yeah. Cooperative receiving.
Right.
Yeah.
Yeah.
The cough dome signals like that kind of interference, it makes them work better rather than worse.
Absolutely. Yeah.
Right, from Zoom. I see a lot of similarities between Open RAN architecture and a mobile edge cloud architecture. Do you see Open RAN working with MEC in the future?
Well, yeah. So, MEC is all about low latency services. So we've got to put compute towards the edge of the network, and certainly for Open RAN, we want to centralize as much as we can for some reasons, and we want to push things out to the edge for other reasons. And the balance for a lot of the processes, and particularly for the DU, is that there's probably a location that we refer to as the edge where we want to deploy. So yeah, we want a single platform that performs all the capabilities of MEC with all the capabilities of Open RAN.
Okay, thank you. Question up front.
Yeah, so having worked for vendors and having worked for operators, and now working for UK TIP, this is somewhere in the middle. You've had 3 major vendors, down to 2.
Yeah.
My experience of vendors is that they're happy to pay lip service to the idea of open systems, but generally speaking, you could argue it's not necessarily in their interest to go for a fully open environment. Have you got any work cut out there? And do you think, as a sort of secondary question, that things like neutral host, maybe in rural areas, for example, or areas that are less well serviced, may be a way for this kind of thing to sort of creep its way in, regardless of what some of those vendors may want?
Yeah. Well, yeah. So with that first part of the question, the incumbent vendors.
Yeah.
In a way that one of the messages is that the traditional architectures are sort of moving towards an Open RAN architecture in some aspects anyway. But you are quite right. Why, if you got a big piece of the pie, why would you put in efforts to lose that big piece of the pie? But also they have to be the best vendors. And if we start deploying Open RAN and they're not an Open RAN vendor, then they're missing out on all of that business. So certainly they've got a lot of the expertise, and so we do need their expertise. In the ORAN Alliance, Nokia and Ericsson are both present. They do a lot of the contributions. So it is partly down to them that it's progressing. So you're right that maybe they're controlling the speed, but it is progressing.
Yeah.
The other point about neutral host, absolutely. Neutral host is about sharing when it's not necessarily in an operator's interest to deploy their own cell site. It just costs too much. If you can share all those costs, then why not? So that makes sense in the areas where the operators don't necessarily compete too much.
Yeah.
A shared rural network, that's a very good candidate for a neutral host. Yeah.
Okay, thanks.
Ian, I'm just conscious of the time. Perhaps we'll have one last question from Zoom and one last question from the audience.
Yeah, we can do that. It's a good one here. He obviously wants to dig up the dirt, Richard. You mentioned Marmite in the title.
Yeah.
Who likes Open RAN and who doesn't?
Right. Well,
that's from Nick, by the way.
all right, Nick.
Yeah.
So certainly, as the discussion that we've just had about the incumbent vendors, there's certainly anyone that's trying to deploy traditional architectures. You might say that they're the ones that don't particularly take kindly to Open RAN. It's a distraction, but vendors that are trying to optimize their existing products, and now they're asked to develop something with a completely different architecture. Everyone's under pressure to roll out 5G as quickly as possible. And you say, well, actually, should you be rolling out that 5G? Why don't you do Open RAN 5G? So it's in the sense of it being a distraction, there's quite a lot of people in the industry that could do without it. In the longer term, I think a lot of those same people would be people that do like it. So
Yeah.
maybe it's a taste that grows on you.
It's
Like
just a
Marmite.
time, yeah.
But I mean, the people that obviously love it, government regulators, because they want to get a more resilient supply chain. The disruptor vendors, so the smaller vendors see it's an opportunity to grow significantly. There's also a role for vendors that weren't necessarily able to build an end-to-end radio solution, can now say, well, I've got expertise in this one area, but now I can sell a component, a commercial X app. And so there's a lot of opportunity for these small vendors or specialized vendors. And so, of course, they love it.
Yeah. Okay.
And question in the audience, George?
You talk about resilient supply chain. How can you genuinely deliver resilience when you've got potentially many tens or maybe even hundreds of application suppliers contributing to your solution? And if part of the reason for moving to 2 vendors rather than 3 was to avoid some of the security risks, how could you avoid some of those security risks manifesting themselves in a different way in the multiplicity of contributors to the Open RAN initiative?
Well, you can't guarantee security, and that's always going to be a question. We have to consistent keep asking that all the way through. But certainly, the one area about this is it's fewer black boxes. So previously, you had a black box. You don't know what processing is going on in between. At least when you disaggregate, you know what's going over those interfaces, and there's an opportunity to spot security weaknesses. But certainly, as you virtualize and you deploy on a cloud and you can deploy in lots of different locations, you're opening opportunities to different security concerns. But they're not necessarily new ones. You know, the guys that cloud isn't a new technology. Hardware isn't new, software isn't new. We're just trying to make sure that the mobile industry is doing security best practice that's already out there. But there's also a lot of effort going.
Ask the question a different way. Do you have a view as to how the lines of code, the number of lines of code, will change as you move to Open RAN from the more monolithic architecture?
That's a tough one.
Yeah, just say no.
I'd say certainly
more vulnerabilities.
Yeah. Well, it's certainly with virtualization. Yeah, it's security is always going to be a tough one. But the what's it called? The UK. What's it called? UK Telecoms Lab. So that's the new lab they're opening this year. So that's going to be focused on security. So I might have an answer that's a bit more thorough and satisfying if I do an update on Open RAN next year. But at the moment, it's one of the things that these activities, all of these DCMS projects have highlighted security. So by the end of these projects, we'll all have addressed what we've developed. Not only is it commercially ready, but is it secure? Because if it's not, then it's not commercially ready.
Richard, thank you very much for your presentation and for taking so many reflections. I know you've put a lot of work into the presentation. We really appreciate that. And thank you for taking the questions from the audience here at the atrium and also from Zoom. So just a couple of things before I close out. The event is being recorded. We will process the video and that will be up on our IET NGEX website probably 2 or 3 weeks time, something like that. But we will publish the presentation. CPD certificates as well. They will be available. Julie will put those up on the website as well, so you'll be able to get the CPD certificates. And if I just roll to the next slide. just want to go through a little bit of a plug for some of our future events. As you know, if you follow the IET Anglian Coastal Local Network, we've got a very active program of webinars. Before I finally close out, I just really would like to thank the organisers and the support team who put the hybrid webinar on today. I'd like to thank our presenter again for all the work he's put in, and the audience here in the University of Suffolk and the audience on Zoom for your participation. Great set of questions, and thank you very much for your participation. And for those on Zoom, you may disconnect now. For those here at the University of Suffolk atrium, we've got tea, coffee and biscuits in the foyer. So thank you very much. I'm closing the event now. Thank you.